Hello friends, welcome to my YouTube channel Engineering Modules. So today I am going to discuss you about transformers. So I am going to discuss about the main definition about transformer and working principle of transformer. I want to show you some diagrams and pictures on transformers and try to explain the whole thing. So let's start. So you all of you show that in the screen that it is a basic outlook of a transformer. So the first question is that what is transformer? By the definition we know that a transformer may be defined as a static electrical device that transfers electrical power from one circuit to another circuit at same frequency but changed on voltage or current or both through a magnetic circuit. So next we go on to the working principle of transformer. So on your screen you all of you see that it is a basic diagram of transformers. You see that there is a primary winding, this is a secondary winding, there have some E1, E2, V1, V2 and I1 and I2 and there are some windings. So now I am trying to explain those things. So now the main question is the principle of working of a transformer. So transformer is mainly work on the basic law, that is Faraday's law. In your screen you see the Faraday's law that E equals to minus d phi by dt. So what is phi? Phi is the induced flux between the windings, those we have seen in the transformers picture. And what is E? E is the induced EMF. So now, when we apply voltage V1 to the primary side of the transformer, then current I1 flow through it. You can choose any of the side as primary side and the other side is the secondary side. So now, then according to Faraday's law, a self-induced EMF is produced. Mainly, transformer is working on the principle of mutual induction. So when we apply voltage and current flow through the primary winding, induced EMF generated, and by the principle of Faraday's law, it transfers or induced through the secondary winding and generate a EMF of E2. But according to Lenz's law, primary induced EMF oppose the applied voltage. So primary induced EMF is almost magnetically same as applied voltage, but it is opposite in direction. So now in secondary winding, E2 induced EMF is produced. You all of you should see this in the picture. So for this induced EMF, current is also produced. What is I2, and this is start flowing through the secondary winding. So voltage that induced in secondary winding, it is the main cause to deliver power from primary winding to secondary winding, and all of this is depends on mutual induction. So this is the basically the working principle of a transformer. Now I provide you about the classification of transformer with respect to working principle. It is two types, step up or step down. All of you see in your picture on the screen that there are two types of transformers. One is step up and one is step down. So what is step up? Step up transformer, which transformer delivers powers through the windings, but the voltage which generated through the primary winding is greater than the secondary winding, is the step up transformer. Secondary winding voltage is more than the primary voltage, but the step down transformer has the voltage in primary winding is more than the secondary voltage. Secondary voltage is less than primary voltage. So this is step down transformer. All of you saw that the transformer has two types of windings in primary side winding and secondary side winding. So in the primary side, its turns ratio is more than the secondary turns ratio. This is step down transformer. And what is step up? Step up transformer has less in secondary winding and primary winding is less and secondary winding is more turns ratio. So these are the basic of transformers, and this is for today. In the next video I am going to discuss you about the transformers with respect to the classification of the architectural transformers. So thank you friends, keep watching and please like, share and subscribe. Thank you.